Hello, this note is on solving exponential equations, and this is the first day for this note. But I just would like you to just squeeze this in on the top right-hand corner of your paper. We've talked about exponent laws, but I just want to do a quick refresher of exponent laws. So if I have a base to the power of m, and I multiply it by the base to the power of n, it's going to become the base to the power of m plus n. So when we multiply, we should add our exponents. So, and this is something you already do, but for example, if I have 5 to the power of 7 times 5 to the power of 2, that's 9 5s being multiplied together, so it's 5 to the power of 9. Also, if I divide, so if I have b to the power of m divided by b to the power of n, just a reminder that that becomes b to the power of m minus n. When you divide, you should subtract your exponents. So for example, if I have 5 to the power of 9, divide that by 5 to the power of 2. 2 of those 5s will cancel out, and then I have 7 5s left over. And then lastly, if I have b to the power of m, all raised to the power of n, so this is a power to a power rule, this becomes b to the power of m minus n. So for example, if you have 5 to the power of 7, all raised to the power of 2, that means 5 to the power of 7 multiplied by 5 to the power of 7, which means that we've got 14 5s being multiplied together. I know I said lastly, but just one quick other note that's really important. If I have b to the power of negative m, it means it's 1 over b to the power of m. So if I have 5 to the power of negative 7, that's 1 over 5 to the power of 7. Okay, cool. So to solve an exponential equation, we want to get like bases, get bases that are alike. And we're going to use our rules to get the bases to be alike. Once we get like bases, then we can set exponents equal to each other. So let's do a few examples. This is review from last year, but let's do a few examples. So for example, right here, if I have 5 to the power of 2x equals 25, well, we know that 25 is equal to 5 to the power of 2. So here we can say this is 5 to the power of 2x equals 5 to the power of 2. And now, because our bases are the same, we can set our exponents equal to each other and say 2x equals 2, so x equals 1. And I've solved for x here, okay? But for example, in question B right here, 5 to the power of x equals 10. 10 is not equal to 5 to some kind of an integer, right? There's no possible way for me to do 5 to some integer. So I'm going to pull out my calculator and see what I can do with this. For starters, I don't need a calculator for this, but I know 5 to the power of 1 is 5. I also have 5 to the power of 2 is 25. So we know that x is going to be somewhere in between 1 and 2. But then we're going to use that to figure out how to get our actual answer. So now we're going to narrow it down. So let's try like 5 to the power of 1.5 and see what we get. And we get 11.18 approximately. So that's too large. So maybe I can try 5 to the power of 1.4, 1.3, and I just keep guessing and checking. Until we get closer. So watch me on the calculator. So I'll try 5 to the power of 1.4. And I get 9.5, so that's a little bit closer. So now I'll try 5 to the power of 1.45. It is a little bit closer, but too large. So I'll try maybe 1.43. It's a little bit too small, so maybe I'll do 435, and I would just keep going and going and going and going. So as we get closer and closer to our final answer right here, we our value right here is going to be like an irrational value, and we need logarithms to solve. But by guessing and checking, we can say that it's approximately equal to 1.43 something, okay? Okay, in our next example, we have different bases. Our bases are not the same, but 49 can be written as 7 to the power of 2, and 343 can be written as 7 to the power of 3. So if I multiply 7 by itself 3 times, I'll get 343. So that means right here that our common base is going to be 7. So now when I rewrite this right here, this would become 7 to the power of 2, and then that's going to be raised to the power of 3x plus 2 right here. I just keep that exponent right here. And then for this one right here, I end up getting 7 to the power of 3, and that's going to be multiplied by the exponent of 3x plus 4. And remember, when you have a power to a power, you have to multiply your exponents. So let's go ahead and multiply our exponents here. So I would get 7 to the power of 6x plus 4, just multiply that 2 through, equals 7 to the power of 9x plus 12. And now that my bases are the same, I can now set my exponents equal to each other. So now I can say 6x plus 4 equals 9x plus 12. Subtract the 6x and get 3x on this side. Subtract the 12, get negative 8 on this side. So x is negative 8/3. Okay? All right, we're going to want to do the same thing over here. Our common base is going to be 3, because 3, I can't break this down any further. But 27 is 3 to the power of 3. So here, our common base. So we're going to rewrite each one of these with that common base. I don't have to change this first term, but I'm now going to write 27 as 3 to the power of 3, and then I'm going to multiply that by 3 to the power of 2x. Now, because this is multiplication here, we're going to use the product rule, which is anything multiplied together with the same base, you can just add the exponents. So I'm going to add my exponents here, and my base is still 3, but then I can add my exponents and I get 3 to the power of 2x. And then here, I'm just going to copy this down right here. Okay, so now I can set these two equal to each other, and I can say x squared equals 3 plus 2x, subtract the 2x and the 3 over. So then I end up getting x minus 3 times x plus 1 equals 0. So that means that x equals 3 or negative 1. And those are my exponents that work here, my values of x here, okay? Okay, so let's take a look at question E now and see what our common base would be for this question here. And when I look at this, I see I have a 5, and I also have 125, and I know that I can express 125 with a base of 5. So I'm going to think about 3,125. So I know that 5 to the power of 1 is 5, 5 to the power of 2 is 25, 5 to the power of 3 is 125, 5 to the power of 4 is 625, and then if I do one more 5, I'll get 3,125. So we can rewrite this number right here as 5 to the power of 5, and that's going to get multiplied by 5 to the power of x squared. And then that's going to equal, and then I can rewrite 1 over 125 as 5 to the power of negative 3, and that's being raised to the power of 2x. And now I'm just going to apply my exponent law so that I can get a single term with a single base on each side. So here, because I have multiplication, I need to add these exponents here. So this side right here, again, there's multiplication here. So this side right here would turn into 5 to the power of 5 plus x squared, because we would add our exponents together. And then on the other side right here, this would turn into 5 to the power of negative 6x, because we have a power to a power, which means that you need to multiply your exponents together here. And now all I need to do is just set my exponents equal to each other. So here I can say 5 plus x squared is equal to negative 6x. Get everything together on one side, preferably the side that makes the x squared positive. And then all I need to do is just factor and solve. So this would be x plus 5, x plus 1, multiplied together to give you 0. So x either equals -5 or -1. And this is my answer right here. Now, this next one, even though it looks like it's an exponential equation, it isn't. But just a reminder that this right here is this exponent of 1/2 means that you are going to do the square root. So 2x to the power of 1/2 is the same thing as the square root of 2x. So here I'm going to say the square root of 2x equals 2 to the power of 2. How do I undo the square rooting? I'm going to square both sides. So I'm going to square both sides right here. So I get root 2x equals 2 squared. I'm going to square both sides. And then I've got 2x is equal to 2 to the power of 4. And then I can just evaluate, right? 2x equals 2 to the power of 4 is 16. Divide by 2, I get x equals 8. Or another option that I have is to divide by 2. So then I get 2 to the power of 4 over 2. So then x equals 2 to the power of 3. Because when you divide, you subtract your exponents and you still get 8. Okay?